Hi, welcome to my video on solving and graphing linear inequalities of a single variable. This is practice number 1, part A. Which one is false? 4 is greater than 1, negative 2 is less than 3, negative 1 is greater than negative 3, negative 6 is less than negative 7. Greater than is when it's on the right, and less than is when it's on the left. So in relation to 1, 4 is on the right, so that's true. Negative 2 is less than 3. Negative 2 on the number line is less than 3 is on the left, so that's true. Negative 1 is greater than negative 3. Negative 1 is on the right, negative 3 is on the left, so that's true. So this must be the false one. Negative 6 is less than negative 7. No. Negative 6 is on the right of negative 7, so this is false. D is the answer. Number 2, place less than, equal to, or greater than in the blank so that the statement is true. Negative 12 is blank to negative 10. Negative 12 is on the left, so it's less than. And here we have to simplify each side. So negative 3 times negative 2 is 6. And notice we have a negative 4. We have the negative of 4 squared. So 4 squared, so that's negative of 4 times 4. So that's negative 16. Just want to go back to this one again. If I had negative 4 in brackets squared, that would have been a negative 4 times negative 4. So note the difference. The 4 is being squared, not the negative. So 6 is to the right of negative 16, so 6 is greater than. Number 3, list the members of each. And this is set Miller notation. This is a set of all x such that x is less than or equal to 4, where x belongs to the whole numbers. So belong to the whole numbers. The whole numbers are 0, 1, 2, 3, 4, etc. So less than or equal to, so we have a 4, then we have a 3, then we have a 2, then we have a 1, and whole numbers contain the 0. So that's the whole numbers that's in belongs to this set. B, the set of all x such that negative 2 is less than or equal to x is less than 5 belong to the integers. The integers are dots. So we have a negative 2, and we have a negative 1, we have a 0, 1, 2, 3, 4, but we're not including 5. So that's the members that belong to this set. And C is the set of all x such that x is greater than or equal greater than negative 3, where x belongs to the natural number. And the natural numbers are 1, 2, 3, 4, etc. So greater than negative 3, you can't have negative 3, you can't have negative 2, you can't have negative 1, and you can't have 0. But you can have 1, 2, 3, 4, 5, and we put 3 dots to indicate they're going on. So that's the natural numbers. Number 4, graph each on the number line. The set of all x such that x is less than or equal to 4, where x belongs to the natural numbers. So equal to 4, and they're the natural numbers, so we have a 4, we have a 3, we have a 2, and we have a 1. There's the natural numbers. We can't go with 0 and the negatives because they're not the natural numbers. Natural numbers are the counting numbers. B, set of all x that x is less than 3 belongs to the reals. So the natural numbers are dots. The whole numbers are 0 and the natural numbers are dots. The integers are dots, but the real numbers are shading. So x is less than 3. So less than 3, I got to do a hollow dot because we're not including 3. And because we're doing the real numbers, we have to shade in the number line to the left. So there it is, the shading. So that indicates all the numbers. Real numbers include the rational numbers and the irrational numbers, so less than 3. Number 4, negative 4 is less than x is less than equal to 2, belongs to the reals. So we're not including negative 4. It didn't say equal to, so hollow. We're including 2 equal to. So 2 is included, so solid. And in between, and real numbers means shading. You get to shade all the numbers in between negative 4 and 2. So there's the shading. So anytime you do real numbers, you have a shading on the number I to include all. Number 5, which one is correct for each? So right here we have just these dots. So we have these dots right here, and to indicate. So it's not real numbers is shading, so it's not this one. Real numbers is shading, so it's not that one. 2 is x is greater than 2, or x belongs to the integers. Greater than 2. So this is the integers greater than 2, so this is the right one. And this is less than 2, so less than 2 would have been down here with dots. Dots. Integers are dots. Less than 2, so it's not this one. So number 2 is the answer. B. Again, we have shading, so it's real numbers. So it's either this one or it's this one. So it's not integers because integers are dots. So it's not integers because integers are dots. So this is less than or equal to 3. Ooh, looks like I got the answer here twice. So what I meant to do was to put just that right here. So let's do this. Let's not have less than equal to for both of them. This is less than or equal to 3. No, it's not equal to, so it can't be that. So this is less than 3, right? So there's 3 hollow dots. So this is the correct one. Sorry for that. I meant to have one of them less than. And let's continue. And number 6, if 8 is greater than negative 2, then 8 divided by negative 2, that's negative 4. Negative 2 divided by negative 2 is 1. So if 8 is less than negative 2, that means that negative 4 is going to be less than. So less than has to go in here. When you divide an inequality by a negative number, the direction will change from a greater than to a less than, or it'll change from a less than to a greater than. So because I'm dividing by negative 2, this sign inequality will go from a greater than to a less than. Number 7, when inequality is multiplied by a negative number, less than equal to becomes greater than equal to. Less than becomes greater than. Greater than becomes less than. Greater than equal to becomes less than equal to. So the direction changes when you multiply by a negative number, inequality by a negative number. So that brings us to the end of this video. And like all my rest, if you like my video, click on the like and the subscribe buttons. And I'd like to thank you for viewing my video and hope the video helped you. Bye-bye.